Hi class. I am homesick today with my son. I apologize for not being there, but I'm going to try this explain everything and hopefully we'll be all set for today. We are starting chapter 10a. It is a two-part chapter on circles, and today is a very basic vocab day, nothing too extreme with this, so I'm thinking that this should work out well. Make sure that you either have a paper copy of day one notes or you have the Schoology copy. If you are the one airplaying this for the class, thank you. And hopefully you are also taking the paper copy so that you're not missing out on notes. At any point, if I'm talking too fast or you miss something, just please ask the substitute to hit pause, or the student that's airdropping this or airplaying it. Okay, so circle is defined as a set of all points a given distance from a given point, which we call the center. Zoom in a little bit. Oops, excuse me. So set of all points a given distance from a given point. Which we call the center. If I were in class, I would cut off a piece of string, place my thumb at one end of it on the chalkboard, and attach a piece of chalk at the other. And because that string length is not changing, I would be able to draw a pretty good looking circle. I will try this for you in the next few days. Center, I'm not going to define that. I'm just going to tell you in this picture, our center is supposed to be at P. So radius, we've talked about before. It is the segment joining the center to a point on the circle, and the word on is key. Okay, so it must be coming from the center, and it must be actually located on that circle. So if I want to list out the examples, well, my center's at P, so all of my segments must have a P in them, and we end up having 3. We've got segment PA, PC, and PG. Okay, a chord is a segment, once again, joining any 2 points on the circle. Okay, so a segment joining any 2 points on the circle. In our diagram from above, DB is an example. AG and AE. Now hopefully you've heard the term diameter before. A diameter is just a chord from above that passes through the center of the circle. A chord that passes through the center of the circle. And I know you can't see my diagram, but hopefully you can look at yours. We only have one diameter in this picture, and that is AG. Okay, next one. Concentric circles are two or more circles with the same center. I always think about a bullseye or a target symbol. Ooh, that's a horrible picture on my part. Let's try that again. I'm not so talented with this iPad. There we go. That's better. Not great. Okay, congruent circles are circles that have the same radius length. So I'm going to say that circles are congruent if they have the same radius length. Next three are quite easy. First one is interior points. Let me zoom in a little bit. Interior points are points on the inside of the circle. And in our picture, I know you can't see mine, but look at yours. We have 4 points that would be considered interior points. Points L, P, H, and K. Okay, same thing goes for exterior points. Points on the outside of the circle. Not too difficult. And in our picture from above, we have 3 exterior points. Points I, J, and F. And I know you're expecting me to say points on a circle, but for points on a circle, I'm going to give you a little bit different definition. I'm going to say a point is on the circle if its distance from the center is equal to the radius. A point is on the circle if its distance from the center is equal to the radius. And in our case, we have 6 examples. Points D, B, G, E, C, and A. Okay, and the last two, which I'm going to explain and talk, just go through a little bit more when I come back, is circumference and area. I know we've seen these before. But circumference of a circle is equal to pi times diameter. Oops. Pi times diameter. Well, first of all, I guess I should ask, what is circumference? Circumference is the length around a circle. So the actual distance around a circle is always equal to pi, that 3.141592654, keep going forever. Use your calculator for that, and times d. Now actually, in all reality, you don't have to use your calculator for that for the most part, because most things will be kept in terms of pi. And an area of a circle, so if I had to fill in that circle, is equal to pi times radius squared. Get very used to these formulas. You're going to see them pretty much every single day for the next 2 chapters and beyond. Okay, feel free to pause at this point if you guys feel like you need to catch up on anything. Just please ask. Next, we're going to move on to the back. Okay, now we're going to move on to the radius chord relationships. First one, looking at our first circle, it says if OD is perpendicular to AB. Well, we know we have 2 right angles then. I'm going to also draw in my radii just to see if I can try to make sense of any of this. And I'm going to go back to chapter 3, and I'm going to talk about congruent triangles. Because of those radii, we know all radii of a circle are congruent. We get congruent there. We've got the right angles, and then I can do the reflexive. Well, I have just shown that these triangles are congruent by, by HL. You're not going to be doing proofs, but I think it's important to see what comes as a result. Well, now that we have that, all the remaining parts, corresponding parts, are congruent. Well, what we're actually able to get at is that if OD is perpendicular to AB, so if my radius is perpendicular to a chord, then I can say AE is congruent to EB. And what that's really saying is if the radius is perpendicular to a chord, then the radius bisects the chord. So I'm going to write that out for us. If a radius is perpendicular to a chord, then the radius bisects the chord. Okay, looking at our next circle. Now we're told that OH bisects EF. Well, we hopefully know that this is just the converse, but proving this and trying to figure out what we can do here. I'm going to zoom in a little bit here. I'm going to once again go and draw those radii in, creating triangles. Pretend that makes a triangle. Well, now I have radii congruent. I have the bisects, which gets me congruent, and then I can do the reflexive. Just looking at this, I can now see that triangles are congruent by side, side, side. And as a result, all corresponding parts are congruent. Well, what we care about is proving the converse. Well, we can now say, as a result of that, that OGE and OGF are right angles. And with a little bit more work, we can then say that OH is perpendicular to EF. Which is the converse. If a radius bisects a chord, then the radius is perpendicular to the chord. And then finally, the perpendicular bisector of a chord passes through the center. Okay, time for us to try some examples. And once again, if you need to, please pause. Okay, we won't be doing proofs, like I said, but we will be doing a lot of algebra type problems using the geometry. So our first example, chord MN measures 24 millimeters and the radius of circle O is 15. Find the distance MN to O. Well, first thing we need is a circle. I'm going to go ahead and zoom in. Ooh, that's an interesting circle. And I know the first thing they tell me is that I have a chord MN. Doesn't matter where you draw it, I'm just going to draw a chord. And I know that a chord touches the circle in 2 points. So I'm going to call that M and N. I'll label that 24 in a second. And the radius of O is 15, so I know my center is O. Well, I need to find the distance from MN to O. Well, let's use what we got. I'm going to use those radius chord relationships to say, if I draw a radius perpendicular to the chord, I will end up splitting that 24 into 12 and 12. Well, that still does not give me the distance from MN to O. That's what I have right here. But I can pretty easily find that if I realize now that the radius, which I could draw from the center to any point on the circle, but would make most sense if I either drew it to M or N. Because now, if I go ahead and redraw that triangle, what I have here is a right triangle with 2 of the sides known as 12 and 15. And we can either use Pythagorean theorem or hopefully use our families. This is a 3, 4, 5 multiplied by 3, resulting in our distance of 9 millimeters. Okay, let's try the next one. Find the length of a chord that is 6 centimeters from the center of a circle with a radius of 10. Okay, once again, draw ourselves a circle. I'm going to draw my chord, doesn't matter where. That is 6 from the center, so what they're telling me here. This is 6 from the center, and a radius of 10. You always want to draw that radius to one of the ends of the chord. Let's see. By me drawing the length from the center to the chord. You can think about that really as a radius, so I know that these are perpendicular. And I now have sides of 6, x, and 10. Once again, Pythagorean theorem, or family, and hopefully you're saying family, 3, 4, 5 multiplied by 2, resulting in 8 for x. And does that mean that my chord has a length of 8? No. The biggest mistake I see on these problems is that people put 8. But in reality, what we've just done there is found out that this is 8 and this is 8, since really that perpendicular bisects here, that radius bisects. Therefore, we can now say that our chord is 16 centimeters. So make sure you look at your drawing before you just go and put your answer down. Okay, why don't you guys take a minute and try 3 on your own. Okay, drawing a circle. Find the radius of the circle if a 24 centimeter chord is 5 from the center. So from the center is 5. Once again, that's like me drawing a radius to a chord, so I know that's perpendicular and it's bisecting it. And that 24 then is split into 12 and 12. And once again, I now have a nice right triangle with legs of 5 and 12, which results in our radius being 13. Our radius is 13 centimeters. And I'm going to try to sneak in one last problem. The bottom here, it's short. If you don't have room, just pay attention. I know that I'm hoping that this is review. The diameter of a circle is 12 centimeters. Find both the circumference and area. Okay, for these types of problems, we want them left in terms of pi. Unless we tell you to round to the nearest 10th, 100th, 1000th, 10,000th, keep it in terms of pi. 99% of our answers, these 2 chapters, will be in terms of pi. Okay, so the first thing I would do is just try to organize what I have. I know that my diameter is 12, and I know a diameter is a chord that goes to the center, which really means that it's made up of 2 radii. Therefore, my radius is 6. Well, having that means we should be all set. Our circumference is pi d. Therefore, in this case, we're going to find out that our circumference equals 12 pi centimeters. And our area, we know, is pi r squared. We found that our radius was half of our diameter, therefore it's 6. Area equals pi times 6 squared, resulting in area equals 36 pi centimeters squared. And that's it for notes. Once again, feel free to rewind or pause if I went too fast at any one point. They are uploaded to Schoology if you need to watch them again. I'm assuming that you will potentially have some good time to work on homework. Homework is day 1 on the new assignment guide. You should hopefully be getting a copy of that if you want it, or it is uploaded on Schoology. I recommend possibly putting the book underneath the projector so that everyone can see it. And a few of the problems are more difficult towards the end, like number 22. Try your best, and I'll make sure I go over those when I return tomorrow. Hope you guys have a great day, and I will see you tomorrow. Bye. Uh-oh.